Welcome to specific heat capacity. We're going to look today at what specific heat capacity is and how we calculate a specific heat capacity. Specific heat capacity is the amount of heat energy needed to raise the temperature of 1 kilogram of the substance by 1 degree Celsius. Aluminium has a specific heat capacity of 910 joules per kilogram degree C, whilst water has a specific heat capacity of 4,200 joules per kilogram degree C. Which of these substances will increase its temperature faster when we heat them? On the next slide you will find the answer, so pause the video here and think about it before you move on to the next slide. Aluminium has a lower specific heat capacity compared to water, so when both substances are supplied with the same amount of heat energy, the temperature of aluminium will increase faster compared to the water. So this means that less energy is needed to raise the temperature of aluminium compared to water. This is the equation that we use for calculating an energy change using a mass, specific heat capacity and temperature change. You will need to rearrange this equation in the exam. I have provided the rearrangements on the next slide for you. Also, make sure you check the units. The easier questions, all the units will be okay in your exam questions, so you can just use them directly in the actual equation, but the harder questions, they will not use the same units as the equation, so they might use mass in grams, or they might use an energy change in kilojoules rather than in joules, so please make sure that you read those units carefully in the exam questions. There are 4 possible rearrangements for the specific heat capacity equation. Make sure that you learn all 4 rearrangements, or you learn how to rearrange the main equation. So this is an example of a specific heat capacity question. You've been given the specific heat capacity of gold, and we need to calculate the energy needed to raise the temperature of a gold ring of mass 40 grams from a temperature of 25 degrees C to its melting point at 1080 degrees C. On the next slide are the workings and the answer, so you may wish to pause the video at this point before you move on so that you can calculate it. In order to calculate this, we need to convert the mass from 40 grams into kilograms, so this is 0.04 kilograms. We also need to calculate the temperature change, which is 1080 minus 25, 1055. Then we can use the specific heat capacity equation, and that will give us an answer of 5,486 joules. The specific heat capacity of aluminium is 910 joules per kilogram degree C, and water is 4,200 joules per kilogram degree C. Calculate the energy needed to raise the temperature of a 3 kilogram aluminium drum, which contains 10 kilograms of water, from 20 degrees C to 45 degrees C. This is a more challenging type of question. On the next slide there will be a hint, so you may want to pause the video before you move on to the next slide. The easiest way to do this is to calculate the energy change for the drum, then calculate the energy change for the water, and add these two together to give the total energy change. So to calculate the energy change for the drum, we do 3 kilograms for the mass of the drum times 910 times 25 will give us 68,250 joules. To calculate the energy change for the water, it's 10 kilograms times 4,200 times 25 degrees C. That will give us 105,000 joules. Then we can add these two values together to give 111,825 joules. Thank you for watching this video. Please subscribe. Also, the website below has a free revision worksheet and mark scheme on specific heat capacity to help with your revision. I hope that's helpful.